Okay, hi everyone. This video is about radians, arcs, and sectors. This is for IB Math SL. So we are going to start with some definitions. The first vocabulary word that I want you to write down is a central angle. And a central angle is an angle whose apex or the vertex, so basically right here, this is the vertex or the apex. So an angle whose vertex is at the center of a circle. Okay, so over here, this is not at the center of the circle, and this is not at the center of the circle, so these would not be considered central angles. I'm only looking at this middle example. So a central angle is an angle whose vertex is at the center of a circle and whose legs are radii. Radii is the plural of radius, so these both are radius is a radius, this is a radius. Together they are radii intersecting the circle in two distinct points on the circle's circumference. Okay, so the angle here that's formed is called a central angle. An arc, which is this red part highlighted here, an arc is a portion of the circle's circumference. And if you think about, I like to think about it as pizza crust. So if you have a slice of pizza, it's the crust. That is the arc, and if you measure its length, it's called the arc length. A sector is the portion of the circle that's included between the radii. So here's the radii, the radius and the radius. It's the area included between the radii and the arc. Okay, so that entire section is called the sector, this entire shaded red section. And you want to think it's the whole slice of pizza. That is a sector. The word subtend means to extend under or be opposite to. So you're going to see this word subtend a lot in the next set of problems we're going to do. So for example, you might see something that says a central angle. Okay, so central angle is an angle that whose vertex is at the center and whose radii extend to the circumference of the circle. So here's a central angle of 105 degrees is subtended by arc AB. Okay, so subtended really means that they're opposite from each other, or that they like this arc is extended out as a result of 105 degrees. They like create each other almost. Okay, so you're going to see the word subtended used, and that's what it means, that a central angle of 105 degrees is subtended, is opposite from this arc AB that it creates. Okay, now I also want to quickly review radians. Radians are also a unit of measurement when we're measuring angles. We're generally more comfortable using degrees, but radians also works. And in our unit circle, a circle is either 360 degrees or it's 2 pi radians. RAD is the abbreviation for radians. So half of a unit circle, or half of 360 degrees, is 180 degrees, and half of 2 pi is just pi. So 180 degrees is equal to pi radians. And again, you can use these conversions to change any degree into any radian. So if 90 degrees is pi over 2 radians, etc., etc., etc. And you can also, since you have wonderful knowledge of the unit circle now, you would know a lot of those benchmark radians and degree conversions. Okay, now we're going to now shift to circles that are no longer unit circles where the radius is 1, but the radius could be 5 or 12 or 7. It could be any size radius of a circle. So in this case, 1 radian is going to be defined by, so again here, we have 2 pi radians. So 2 pi is really like 6 point something, because 2 times 3.14 is greater than 6. And pi radians here is about 3.14 radians. That this is 3.14 divided by 2 radians. Here I'm talking about, what if I scale to 1 radian? So 1 radian is going to be defined as the size of the central angle, so here's the central angle, subtended by an arc with the same length as the radius of the circle. So let me say that again. So I have a circle, this is a radius, 1 radian is going to be equal to the length of this arc that has the same measurement, same radius, or same measurement as the radius. Okay, so this arc length is going to be r. It's the same as the radius, which is r. Okay, so if I have 2 r's, so if this is 1 r and I move to 2 r's in this example here, here was 1 r, here was 2 r, this is going to be called 2 radians. Okay, and that's how we're defining radians, and you're going to realize it's actually much easier to work with this way, by this definition. Okay, so I am going to start with degrees first because I feel like people usually can understand degrees better, and then I'm going to show you that's the exact same concept for radians. So example number 1, we want to find the arc length of BC. So here's my arc. I want to find its length. I know the central angle is 75 degrees and the radius has a measurement of 10 inches. So the way that you would solve this is you would actually set up a proportion. And a proportion I'm going to set up as my central angle is to the entire measurement of the number of degrees in the entire circle, which is 360. So it's like part to whole, and then we're going to do part to whole. Okay, so central angle is to the whole circle, which is 360 degrees, as your arc length is to the entire circumference of the circle. And the entire circumference of the circle is found by 2 pi r. So here I'm just filling in, okay, central angle 75 degrees is to 360, as I'm calling my arc length x because that's my unknown, is to 2 times pi, and times my radius. I'm plugging in my 10 inches radius in. Okay, I use my calculator to multiply 2 times 3.14 times 10, and I get 62.8. And now to solve for x, I can multiply both sides by 62.8. And so in my calculator, I'm going to do 75 divided by 360, and I multiply it by 62.8, and I get x is equal to 13.1 inches. So I just figured out the arc length by using proportions. I'm saying the area of my the measurement of my central angle is to the entire whole of 360, as the measurement of this portion of the circumference is to the entire circumference, and I'm basically solving a proportion. Okay, so we're going to do the same exact thing, but now instead of a measurement in degrees, we're going to use radians. So on this page, I've taken that last example and I've put it in the corner over here so we can refer back and that we are doing the exact same thing. Okay. Now here, we want to find the arc length of AB, and instead of giving you an angle in degrees, I'm going to say theta stands for a measurement in radians. Okay. Now I'm actually doing a general case, so this works for any radians, whether it's 1 radian, 2 radians, 3.14 radians, or pi over 2 radians. This works for any measurement in radians. So I'm going to do the same thing. Radians is to the total number of radians in a circle, and that was 2 pi, remember? So the radians you're looking for out of the total number of radians in a circle, which is 2 pi, is equal to the arc length to out of the circumference. So radian is to the entire circle as the arc length is to its entire circumference. Okay, so circumference here is 2 pi r, I plug that in. I'm trying to solve for the arc length, so I multiply both sides by 2 pi r, just like I did over here. I multiply both sides by 62.8. Okay, so this cancels out with 2 pi r and 2 pi r cancel out, and so I'm left with arc length is equal to, and over here on the left-hand side, this multiplied by 2 pi, this divided by 2 pi cancel out. So I'm really left with just plain old r times theta, your radius times your theta. So your arc length is plain old, all you have to do is multiply your radius times your theta. So I rewrote it one more time. Your arc length is equal to L. So on your formula reference sheet, they give you this, and they call it L, and they write it as radius times theta, but they do theta times radius instead. Okay, so let me show you that formula reference sheet. Here it is, the length of an arc, they use L, they write it as theta, which is radians, times your radius. Okay, however, whatever measurement this is. Let me show you an example. Example 3, find the length of the arc, so basically find this length of the arc which subtends a central angle of 2.6 radians in a circle of radius 7. Okay, so radius r is 7, theta is 2.6. How do I find the arc length? Well, if we use the formula that I derived from the last screen, To find the arc length, all I need to do is multiply radius by theta, r times theta. So 7 times 2.6 is 18.2. And that is the beauty of radians, is that you can just multiply them together. You don't have to, well, we got that from setting up the ratio, the proportion, but it always simplifies down to the radius times the theta. All right. Now, part B is going to ask us to find the area of the sector. So I'm going to show you how to derive the formula for finding the area of the sector. Okay, and notice the formula is on your reference sheet, but I'm going to show you where it comes from. Okay, so finding the area of the sector is the same concept. We're setting up another proportion. We're going to say the angle theta is to the total number of radians in the circle, as the area of the sector is to the total area of the circle. Okay, so we're just setting up another proportion. So theta is to 2 pi, because I know there are 2 pi radians in an entire circle, theta is to 2 pi as the area of the sector is to the entire area of the circle. Well, how do I find the area of a circle? I do pi r squared. Okay, so I plug that in there. I'm trying to solve for the area of the sector, so what I need to do is multiply both sides by pi r squared. So here I multiply both sides by pi r squared. These cancel out, so the area of the sector is equal to, now over here, this pi and this pi cancel out, and I'm left with r squared times theta divided by 2, which is right here, r squared times theta divided by 2. I ended up switching the order of these because on your formula reference sheet, they put the theta first. So area of a sector, they use the letter capital A, is equal to a half of theta times r squared. Okay, and this is the same thing as saying theta times r squared divided by 2. But this is what they have in your formula reference sheet. See, this is what they have. Okay, so here I showed you how they got that area of a sector formula. And now we're going to actually find the area of the sector. So back to that same example, what would the area of the sector be? So if I use the formula which says take your radians, multiply it by your radius squared, and divide it by 2. So I know my central angle is 2.6 radians. I multiply it by my radius, which is 7, I square it, and then I divide it by 2. Put this in my calculator, and I get 63.7 centimeters squared. Okay, so from watching this video, you've learned how to calculate the arc length and area of a sector using radian measurements. And just to review, let me go back to the formula reference sheet. We can find the length of any arc by multiplying the central angle measure in radians by the length of the radius. And we can find the area of any sector by doing half of the central angle times the radius squared. If you have any questions, please post to classrooms. Thanks for watching.